Hey everyone, welcome to a new video. This time it's an accompanying video to the post I made recently on my blog, which is called Getting Started with Consul on Kubernetes. So if you're interested in that, just go to blog.bako.info and you'll find a written description of what we're going to do here in that post. Now, basically what we're going to do today is something quite simple. We're just exploring how you would install Consul on Kubernetes and then use the features of Consul. If you're not entirely sure what Consul is, we can be quite brief about it because it does a lot, of course. Basically, it's a networking tool. It's not just something for Kubernetes only, it's also for other environments. And it allows you to do a couple of things, like, for example, defining services, letting your applications register these services, letting other applications find these services. You can also secure service-to-service communication with mutual TLS without you having to modify your code. Also, you can control the traffic between your services with something which is called an intention, and much more than that. Now, instead of just dwelling on all these features, let's just get started and install Consul on Kubernetes and see how that works. Now, I decided to install Consul on Kubernetes using Pulumi. If you don't know what Pulumi is, there are some videos on my channel where you can find more information. Now, basically, what you see here on the screen, I'm in the folder that contains all the Pulumi files. By the way, I'm using Python here with Pulumi. I also activated a virtual environment here. That one contains all the packages that we need for Pulumi. And basically, our application that deploys Kubernetes, but also the software Consul that we require, is all in this main pie here, right? And the only thing I have to do is I have to do Pulumi up here, Pulumi up. And because I already have a connection to my Azure subscription using the Azure CLI, Pulumi can just use that. Now, I have these files on my GitHub as well. So in the description of the video, you'll find the links to the GitHub repository where these files are. In this case, we're going to do Pulumi up. And yeah, just like with other tools you might know, it will do first a preview. Check out all the resources that will have to be created. So we're basically doing a plan here and seeing what will be deployed. Let's give that some time. But you should see that we will deploy both Kubernetes plus a couple of other things on top of Kubernetes. And there we go. So what we do here, we're going to have a resource group, of course, a virtual network and a subnet within Azure. We're going to then deploy a Kubernetes cluster. Then we use the Kubernetes provider in Pulumi to get access to this cluster. We create 2 namespaces in the cluster, and then we deploy 2 charts in the cluster. And in this case, the chart we're going to deploy is the Consul chart. And so you'll find the Consul chart on the web with full instructions on how to install it. Now, I'm going to just kick this off, let Pulumi do the actual installation. And then I will quickly move to the chart and how that is installed on Pulumi. So let's take a look at that while he's busy doing this. I have this also on my GitHub in my Pulumi samples, so you can go there again, and it will be in the link in the description. There will be a link to that. And that's the one which is here. So this is the actual Pulumi app. And if I open this, what you'll find is that, of course, there's some code here that imports the correct packages. We get a SSH key as well from our configuration. Then we create a virtual network, a subnet, and the actual Kubernetes cluster on Azure in this case. So these are the properties which are specific for AKS. and the underlying provider from Terraform is actually used to create these resources. Right? Now that's great. When the Kubernetes cluster is deployed, we're getting access to it by using the Kubernetes provider that Pulumi provides to us. Now we can use that Kubernetes provider to create a couple of namespaces. So first of all, I want to create a namespace called Consul, because I will install Consul in that namespace, so there's nothing specific or special there. I also am going to install Flux, because the actual application will be installed using a GitOps approach. We'll use Flux to do the deployment of an application that uses Consul, as you'll see later. So Flux namespace, and then we deploy the actual Consul application. Of course, because it's a Helm chart, it's relatively simple to deploy because it's fully packaged for you. So we deploy a chart. The chart is called Consul chart here. It's in a local path. So I fetched the chart. In this case, it's coming from GitHub, actually, the chart. So I downloaded that one into my Pulumi project. As you can see it here. Here's the Consul chart. Here's the values YAML file. So I refer to the chart by referring to this directory here using the local chart opts within Pulumi. Now, a chart typically will have to provide some values in the values.yaml file. Now that is a quite long file with lots of information in it. In this case, we just do the following. So we enable connect, we enable the clients as well, and the catalog of services. That's a couple of things that we do here for a very basic Consul installation. So there's nothing like ACLs or TLS configuration and so on. So this is not production ready either. And this is great for testing, for learning. When you do a production setup of Consul, well, you could use a chart, but then you would have to also supply several other options to make this a secure deployment, right? So Consul gets deployed, and then Flux gets deployed as well. I have the Flux chart also here. There I used Helm fetch to get it from the Helm repository. Same thing here. There's a values YAML, and we provide these values here. So here I'm deploying Flux. I link Flux to a specific GitHub repo and a folder in that repo called config. So later, when we configure Flux, we will ask him to pull YAML files that deploys applications from this Git repository. That's fairly simple. There are some videos about Flux on my channel as well, if you're not sure about what this actually does, right? So that's it. So the chart installation for Consul, what we're doing here today, this is it. So in Pulumi, that's quite simple to do, and that deploys the chart for us. Probably this is now well underway creating the AKS cluster. Yes, it's being created. If we go back to the user interface or the portal for our in our Azure environment, we click refresh, and there we see the cluster being created by Pulumi. I can also see that because I wasn't explicit in my names, so then Pulumi will also add some characters there to make the resources unique. That's a choice that you can make there. I let it be the way this it is. So we leave it at this for a moment, and then when it's finished, we come back and we'll see what we can do deploying our applications that take advantage of Consul. Okay, so the installation is complete. Kubernetes was installed and the two charts were installed as well. That means we can now check out on Kubernetes level if this all worked okay. So let's just do that, right? I will use the Azure CLI, so Azure AKS list -o table here to list out Kubernetes clusters in my subscription. There should be only one, and I will use as AKS get credentials to obtain the credentials to access this cluster using the public API point that we get from AKS. So I use the name. The name is this one. And we also have to specify the resource group. The resource group is this one. Yeah, and make sure that I have a space in between. And that should be enough to get the credentials to our cluster. This will merge the configuration in our current config file for kubectl or kubectl, whatever you call it, and then we do kubectl get nodes to actually check out if we do have that connection. And I deployed in Pulumi. In the configuration, you will see that there are 3 nodes being deployed. I see those 3 nodes over here. That's one thing that we have. If we list the namespaces, we should see that there's a Consul and a Flux namespace. And if I'm doing a get pods for the namespace Consul, we should see that the Consul application is running there. What you'll see here is that there are 3 servers deployed. These are the server agents. We also have 3 client agents. So 1, 2, 3, these are the client agents. Our application, we'll see in a moment, the application that we use will use the client agents to connect to Consul. But that's something we'll show in the application that we have provided as an example, so to speak. So Consul is now ready and is being deployed. Now we're going to make our life a little bit easier and connect to Kubernetes using the Visual Studio Code application. So I'm going to open one of my code applications here. Let's just take this one. And this one is the contents of the repository that I connected Flux to. So later we'll deploy applications to our cluster. And we'll use this YAML file that you see here in front of you to do so. I don't need that right now. I'm going to check out on the Kubernetes level. Also look at the Consul deployment and see if we can get a user interface, a UI that that allows us to check out the Consul deployment. So I have a couple of stale ones here, but this is the active cluster. Let's switch the namespace to Consul. So use this namespace. And then within the namespace of Consul, you'll find there's some networking services being created. And one of those is the Consul UI. Yeah, so Consul comes with a user interface that you can look at to see what is going on there. It's not exposed by default using a public load balancer, so I don't have a public IP to connect to. But of course, I can use the port forward feature to port forward the port of the service internal to the cluster to a local port on my system. So I'm going to port forward 8888 to port 80 because that's the port of the service, and that should start up another terminal where the port forward is happening. And then we can very simply go to localhost 8888. And once we do that, we see the Consul UI there. Now, there's not that much to be seen at this point in time. What you do see here is the list of services that were defined or are available to Consul and for applications to query. And of course, Consul itself it has its own service, so the Consul service. We're not right now too interested in that. And then what you can also see is that some other services were automatically detected by Consul because these are Kubernetes services. And what Consul is actually doing, based on our installation parameters of the Helm chart, it will detect all these services and then specify the name of the service and then the namespace where the service lives. So for example, you see here there's a Flux service, well, it's in the Flux namespace. So these are automatically made available to you as part of a discovery process within Kubernetes actually. Of course, you can see the nodes which were deployed, and here you see again that we have 3 server nodes, where one is the leader, and then we have 3 client nodes, and it looks a bit strange here maybe, but the client nodes, they look like your Kubernetes host servers, and that's indeed the case. The the Consul client exposes a port on your Kubernetes servers. Yes, we'll see that later also in a diagram, and we'll also see how then to connect from a client application to Consul using the ports, these static ports which are available on your Kubernetes hosts, right? Okay, now There's also, as you can see here, a key value store for configuration data. A bit similar to etcd and so on. In this case, it's within Consul. I'm going to create a value here because I know I need it for later. I will need a value that my application is going to query, and the value is called Redis pattern, and it just needs to be an asterisk. So I'm going to save this key value pair. Of course, pretty basic and pretty simple here. You'll see later how we will use that. For the rest, we won't go into details about ACLs or intentions. Maybe for another post, we'll look at the connect service mesh possibilities and intentions to, let's say, to control service-to-service traffic, but that's for another time. So we know now Consul is set up, it's running. We even added a key value pair here. The question now becomes, how does an application, or an application that we write, how does that one use the actual Consul environment to do queries for services or key value pairs, etc. So we look at that, but before we do that, let's look at a diagram about how this actually works. So this is the diagram, simplified diagram of a Consul installation on Kubernetes. As you can see, in my case, we have 3 Kubernetes nodes were deployed, and you have already seen that there are Consul servers. These servers are deployed as a stateful set in Kubernetes, and all of these pods, so the pods of this stateful set, they all have also a volume map to it. That's an Azure disk in this case, and that's of course used, for example, to store your key value pairs, etc. As I said, your application, so an app, will not connect directly to these servers here. They will connect to a Consul client, which was also installed by the chart. The Consul clients are installed as a daemon set. Now, the daemon set, of course, means that for every node in your cluster, so our 3 nodes, will get that Consul client installed. Now, what the client is doing, you can see that here, the client exposes a static port 8500, on the Kubernetes host. That means that your app can use, let's say, some tricks. It's just a downward API, as it's called, to connect to the client. But it has to, of course, the app has to find out what's the host I'm on, what's the IP of the host. And with the IP of the host and the port that you know for Consul, you can actually connect to the Consul client living on the host. Now, that's a lot of talk about this. Let's just see how this works in a bit more detail. And we'll look at that from the perspective of the application. I have my application here, which is a very simple Go application. So my application is actually doing the following. So let's just go to func main, where everything starts. What you can see here is we specify the Consul address. My application needs to know where Consul is. Now, as you can see as well, we're using a function which is called getEnv. And that function, we use that to retrieve a environment variable that's available to the pod that our application is running in. I called it Consul HTTP address, or ADDR, and that one needs to be set. If it is not set, that will be a fatal error, because that environment variable is not set. We cannot continue because I need Consul for my application to work properly. From the moment that the Consul address is set correctly, we can use, in this case, the get Consul function, which is here, to obtain a client to Consul, using this one here, a pointer to Consul API client. And then that client can be used later to, for example, get access to the catalog functionality, which allows us to query services, but also gives us access to the key value pair store to retrieve what in our case we need is the Redis pattern. That's why I added the Redis pattern earlier, because I need it in my application as a configuration value. I want to know what kind of pattern subscribe in Redis I can do. If you don't know what that is, that's not too important. It's just a configuration value that I need in this case. So that's great. Of course, the question is, and you can look at the code on GitHub, of course. Question is, how do I set this? Because this should refer to the IP address of the Kubernetes host that I am running on. Well, for that to work properly, let's go to the repo that's used by Flux to deploy the containers. And as you can see here, in the container spec of my deployment, you see here the container spec. I'll just make it a little bit larger. You see that we are setting some environment variables. Redis host you can skip, that's not too important. But then you see here, we retrieve the host IP. So that's the way, what you see here, what's under the host IP, that's the way to retrieve the IP of the Kubernetes host that our application is running on. And what you see here is actually the use of what we call the downward API, and we obtain the host IP from the status field here. So this is what gives me the host IP of my Kubernetes cluster. And then, of course, I can construct the Consul HTTP address that I need in my application as an environment variable. I can construct it using what I found here. So it's HTTP//, of course, the host IP, and then 8500. That port is the port used by Consul to connect with. So that's simply the way that we give our application the address of Consul to connect to. Of course, the question is, we now have to deploy this. Excuse me. Now, how do we do this? Because this is living in a repository within our environment in GitHub. We need our cluster to give our instructions to the cluster to deploy this actual application. Let's take a look how this works. And in our case, we can use Flux CTL for that. So Flux CTL, of course, I installed this already on my system. I have my Kubernetes connection in place as well. So I can use Flux CTL identity to obtain a SSH key that I need for GitHub. I will need to provide the namespace here. So I'm going to provide K8S and then the namespace, which was Flux. I installed Flux in there. And of course I should use -- and then you'll see that I get my SSH key here. Now don't worry, this one will be very short-lived. By the time you watch this video, that key is gone. I'm gonna copy this. We're going to go to GitHub. And in GitHub, in the Consul demo, in settings, I'm gonna set my deploy key. And by the way, this is all Flux specific. This is what we do for Flux, to give Flux access to my repository where my YAML file is, so he can deploy the application. I'm gonna call this Flux. I'm gonna paste the key over here. I'm gonna allow write access, and I'm going to add the key here, confirm with my password. And now Flux should be able to connect properly to this repository and deploy the YAML that you have seen earlier. So this one over here, this YAML file will now be gotten from this repository, and Flux will install that. Now I've set the update for Flux for every minute. So that means that, yeah, in a short while, this service will start to work. Let's check this out. So I will activate the default namespace because that is where our application will be installed. And then after a moment or two, in the list of workloads, there should be a deployment for Redis and for my real-time app. And as you can see, it's there already. So Flux is doing its work and is installing the YAML file you see in front of you. Now let's check out if my containers are actually working. So we're gonna check them out and see what they're doing. Now, of course, they're still red here. Let's see if the Redis app is doing its thing. Yeah, Redis is already deployed, so that's good. And then let's check out, these ones will become green as well, because there can be a bit of a race condition. They will fail if Redis is not available, but from the moment Redis is available, they should normally be able to start properly. Great, let's check out the log file here. So let's show the logs. And indeed, there we see, first of all, we see this here, service address and port. What is that? Well, as you can see, in the Go application, we also use a little bit of code to retrieve service information. So in this case, we use the Consul catalog, and we're asking, well, there should be a service somewhere in Consul, which is called default Redis. Why? Because the Redis service creates, or the Redis application creates a service called Redis in the default namespace. So we can create that from Consul, and then we can get the service address, the IP, and the service port that was registered by that service. So that gives us indeed the log file output. Service address and port is 10.10.36. That shall be the IP address of the Redis service that we are running here. So if we check that out, the Redis service, we check out the IP is 10.10.36. Yes, 10.10.36. So that's perfect. Then of course we see here from the key value store that the Redis pattern was obtained. Indeed, the Redis pattern was obtained. It's an asterisk. This is just our connection to Redis. We do a ping to Redis, we get a pong back. And yeah, our pattern subscribe in the application worked as well. Nothing too fancy here. So we just do a subscription to Redis by using a pattern subscribe, and we use the Redis pattern value from the key value store of Consul to obtain that value, which in our case is just asterisk. Not important, it's just that we can use that configuration value there. Now let's see if the application actually works. Does it work or does it not work? Well, let's check out. We have our real-time app service here. That one should normally have a public IP. That's this one. Yes. Let's check out if on that public IP, which is running on port 80, we have some application running, and indeed it's this one. There are no messages coming into the Redis backend. They would normally be displayed over here. Okay, we won't do that. We know now that the application is up and running. So what have you seen? You have seen deployment of Kubernetes and Consul, in our case with Pulumi, but that doesn't really matter. It's a Helm chart installation. So if you do it yourself manually based on the Helm chart, it's just as simple, nothing special with that. But then we have shown that you can just basically use any application written in any language. It doesn't have to be Go, of course, to first of all obtain a connection to Consul using the Consul agent, which is supplied to us via an environment variable, and we use a downward API to fill up that environment variable with the IP and the port of the Consul agents, and then we can simply use Consul to query the catalog to get key value pairs and use that in our application. Now this is very basic use of Consul, but you have to get started somewhere, right? You'll find in the description of the video, as I said earlier, the links to all the GitHub repos and so forth, where you can find the code. And together with the blog post I've written earlier, yeah, you should be able to get started quite easily by installing Consul and following the same steps here. That's it. Thanks for watching. See you another time.